Okay, I'd like to talk to you about variance and standard deviation. A lot of times you'll see two formula for variance and standard deviation. You'll see, get a pen here. Oops, my pen didn't show up. There, that should do it. You'll see the sample variance. I'm going to just put VAR for variance, and you'll see the population. And I'll put POP for the population. And for the sample variance, you'll see a Greek character sigma representing add. Then you'll see parentheses x minus the mean. And then you'll square it. And then you'll have n minus 1. And for the population, you'll see the same thing. Looks like our minus sign didn't want to stick around. Divided by n. Okay, let's say we have a class where we have 4 people, and well, actually let's represent it two ways. One where we have an 18-year-old, let's say we have a 19-year-old, a 21-year-old, and a 25-year-old. And if it's a sample variance, it might be a class of 45 people, and I just took a very small sample of 4 people. If I'm doing population variance, population means I'm taking everybody. I've got a very small class of just 4 people, and there they are. So those are my x's, those 4 ages. So let's write down I'm going to be looking at the 18, 19, 21, and 25. So those are my x's. Let's subtract the mean from each one. The mean that I calculate is 20.75, which we put all the way down here. So we're subtracting 20.75, our mean, from each one of them. Some of our lines want to disappear here, huh? Okay, there. They stayed, yay. Now, notice, all we're really doing, if we subtract the mean from each one, we're just saying how far away from the mean. How much do you vary from the mean? Well, 18 varies, what, about a little over 2 years less than the mean. So I subtract that, and I calculate it's negative, it's less, and it's almost 3 years, 2.75 years less than the mean. 19, well, that's going to be 1 less because it's a year older, so 1.75 years younger than the mean. And then 21 is going to be 0.25, a little over the mean, and then we have 4.25. So 25-year-olds, a little over 4 years older than the mean. So now we just did x minus the mean up here. Now we need to square all those terms. Well, 2.7, so now let's square them. Yay, it's very squared. So let's square. 2.75 squared is 7.5625. And then we have 3.0625. If I square 1.75, square 0.25, well, so 0.25 times 0.25, I calculated it's 0.0625. Hopefully I got that right. And then 4.25 squared is 18.0625. Now, so now we took x minus the mean. We squared each of the terms. Notice I have to square them individually. Now this summation means add them up. We add up the 4 numbers, and when I add them up, I get 28.75. Well, that gets our numerator, 2875. Well, now I need to divide by n minus 1. N minus 1, well, I have 4 ages right here. So there's my 4 ages. And I need to divide by 4 minus 1, which is 3. which I calculate to be 9.55833. That's my variance, and that's specifically my sample variance. So there's my sample variance. Now if it's population variance, I take the 28. Now notice it's the same thing on top, so I take the 28.75 and divide by not 3 but 4. So let's take our population. I'm going to write it up here. So population variance, which is 28.75 divided by 4. And that is, what is 28.75 divided by 4? I calculate 3.095, 3.0957. Okay, so now I have my population variance, which is just 28.75 divided by 4. There's my population variance. Actually, I probably should surround both. And there's my sample variance. Now, how do I turn those into standard deviations? Well, standard deviation just means you take the square root. So standard deviation. So I take the square root of, what, 9.583. I guess I better take that a little bit longer. And I get, what do I get? 7.1875. And if it's, so there's my standard deviation. 7.1875, just the square root of it. Now what about my population standard deviation? So let's draw a line up. So I just take the, shall we put it right here? So we're going to put standard deviation. And actually let's put a different color to make sure it's clear which ones I'm doing. Population. So here's the population right here. And so I'm going to just show that that goes with that one. Here's my standard deviation, which is the square root of what? 3 point. So I'm just taking this number right here. So I take 3.0957, which is equal to what I calculate is 2.68095. So that's my standard deviation. This is for the population over here. And this over here, let's do it back in black. This is for the, actually I'm not going to write there, I'm going to put it right here, sample. The one that's normally used is the sample standard deviation. Normally you don't have a population. Normally, you know, for example, if you're trying to do the United States, that's over 300 million. It's very expensive to get. So we normally just do this sample standard deviation. In fact, if in Excel, if you put the formula in for standard deviation, it gives you the sample standard deviation, where it divides it, remember, by 3 over here, rather than 4, which is what the population would be. But sometimes you'll be asked, well, population standard deviation. But just remember, this one right here, the sample, is your normal one.